All right, picture this. You're standing in the middle of a huge mining site. The company already drilled samples in a few spots, and each one has a different amount of copper or gold in it. But here's a million-dollar question. Where should you dig next? That decision isn't random. It's based on math, specifically geometry.
I use math every day. Math, chemistry, I like to say that chemistry is just math with letters basically. And so we use a lot of math, we balance the circuit. And so one of the jobs that a metallurgist can have is to make sure that we are recovering as much of that mineral as we possibly can. And so we're using a lot of math to say, okay, what's coming in the front end, what's going out the back side of the processing plant? Did we recover all of that material? If we didn't, why not? Can we recover more of it? Is there something we can do to optimize that process? And so we're doing a lot of math to balance the streams in the plant. So math was my favorite subject in school, which was a lot of fun. Math has always been fun for me. I've always really liked it. It's a bit of a puzzle you can always figure out the solution to, and I kind of enjoyed having that sort of puzzle to work on. And I find myself kind of doing the same thing now, just always having a puzzle, always trying to figure out the answer.
I did not particularly enjoy calculus, and calculus is definitely something more of the engineers would use. Geology is more geometry and basic math. I don't feel like I particularly excelled in a lot of the higher level math, and geology is perfect for me in that regard. But overall, the math that I have to do on a day-to-day basis comes so naturally to me now. In the geology department, since we have to decide the exact dimensions on how we want rock to be broken out of the ground, we need to decide dimensions on all of those rounds. And that includes slabbing, and that includes also estimating the grade, which we usually do just by mental math on if we think a face looks good, if it's gonna make cutoff, if it's gonna make my money, or if we're really having a loss on cost there. So that kind of math. We do addition, lots of subtraction. We do a lot of geometry, lots of SOHCAHTOA, cosine, tangents, all those things. And for estimating grade, it's all just mental math, quick addition, subtraction, division. And some of us carry little underground calculators, but for the most part, you can do it all in your head.
Let's turn this mine into something we can work with. A coordinate grid. Each of those sample spots becomes a point on the grid with different coordinates, and each point tells us the mineral concentration at that location. Now, imagine the mining company wants to dig at a new location, right here. How do we predict what's underground without digging first? That's where a simple model called the nearest neighbor estimation comes in. It's exactly what it sounds like. You look at your neighbors on the map, find out which sample is closest, and assume that the new location will have about the same concentration. So, if point C is the nearest neighbor, we'll predict that our new dig site probably has around the same amount of copper level as point C. But how do we actually know which one's closest? That's where our old friend, the Pythagorean theorem, comes back to work. If you've got 2 points, let's say 2, 3, and 4, 2, you can think of them as forming a little triangle right on our map. To find the distance between them, you use this formula. It's just geometry. We're finding the hypotenuse of a triangle. And when we do that for all our sample points, the one with the shortest distance wins. That's our nearest neighbor. This simple idea, measuring distance on a coordinate grid, helps real geologists make smarter choices about where to dig. It's fast, visual, and surprisingly effective. In fact, some mining companies start with this exact method before moving on to more advanced ones, like something called the inverse distance weighting, which gives more influence to samples that are closer and less to ones that are farther away. But every complex system starts simple. And this one starts with the distance formula.
I really like math. I was in some advanced classes in high school, and then even in college. I went to be an engineer, and then changed my mind in the end, but ended up taking a bunch of calculus classes. So it works out really well in the industry. When we do different things from day to day, some days I'm doing molar mass calculations, trying to figure out, some water chemistry type things. Other days I'm doing more engineering type math, so like algebra, that kind of thing.
It was one of my top two. Math for me is like a puzzle. I love puzzles. Every aspect of my job, I use it. So as far as, making sure the inventory, purchase order receipts that we receive every day match the purchase order, making sure our general ledger accounts balance. There's really nothing that you don't use math for. So even making sure my coffee has the right number of special shots in it. So, you got to use math all the time.
So let's recap. We take our sample data, plot it on a coordinate grid, use the distance formula to find the closest sample, predict the new concentration based on that neighbor. That's math helping us see patterns in the Earth itself. So, the next time you're wondering, when will I ever use the distance formula again? Just remember, it might help you find gold. Or at least copper. Thanks for following along.